Hence, so let's start again. We're reviewing what is functional interface and what is lambda expression, and then we will take a couple of examples again related to lambda expressions, how to implement lambda expressions, continuation to last session. Okay, so generally we know the concept of interfaces. So what is the point of interface? When we are going to derive or create interfaces in our Java applications, we know that. So interfaces generally contains only abstract methods. That means an interface is always defines what has to be implemented at a class level. Okay. So that is how we will create abstract methods as part of the interfaces. But generally in this case, it is a functional interface. So here, this concept being introduced from Java 8 version onwards. So that's why it is called as Java 8 feature. So what is the purpose behind functional interfaces? Here it is. So there is a fundamental, okay, declarative programming concept is available. So that's why they came up with this concept, and associated to this topic, associated to this concept, functional interfaces, we do have a lot of other connectivity concepts also, like lambda expressions and so many other things also. So that means to make sure implementation of lambda expressions functionality, we have to understand always functional interfaces. So what is the difference between interfaces and functional interface? We had a discussion in the last session. So generally, and overall, a functional interface is nothing but an interface which contains always one abstract methods. So it should contain always only one and only abstract method, not more than one, not zero also. So that is what called as functional interfaces. And as part of functional interfaces, we can add static and default methods, any number of static and default methods. So there is no restriction for static and default methods, because we know a concept in interface from Java 8 version onwards, they are allowing to add static and default methods with an implementation. And what is a static and default method? That is also we discussed in the our previous sessions, right? So those we can decide, those we can define as part of functional interfaces, whether zero or more. So you can add more than one static method or zero also, similarly default also. But when it comes to non-implemented method, abstract methods, one and only abstract method has to be added into functional interfaces. So that is what those interfaces will be called as functional interfaces. So now can I call this as a functional interface? Means no, because zero abstract methods. Now can I call this? Means no, because two abstract methods. So when it comes to here, can I call? Means yes, this is a functional interface. Why? It is having only, this interface is having only one abstract method. Yes, this can be called as functional interface. Now here the problem is, maybe somewhat I can call it as a functional interface, but tomorrow when I mean one, there is a chance to add one more abstract method to this functional interface. So this, because an interface can contain in general more than one abstract method. So that means or zero also. So that means I may delete it, I may add one more method, one more abstract method, like that. So to avoid all these accidental issues, so what Java is doing here, it is they provided a annotation called as functional interface annotation. So what is annotation? Although we discussed in our previous sessions. So now if you are added this annotation at interface level, so this annotation will make sure always only one abstract method available as part of the interface. If you deleted existing abstract method, then also you will get the compile time error. Or if you are trying to add more than one abstract method, then also you will get the compile time error. So that means this annotation is making always an interface is 100% is functional interface, and it is making sure like not violating the functional interface, like single abstract method functionality, single abstract method functionality. So that is why we have to use this annotation, functional interface annotation, whenever we want to create functional interfaces along with regular interfaces. So that is what we discussed in the last session. So I'm just going bit means we taken almost 1 week gap, so that's why I'm just revising all the things. And that too, I told you already, if you want to become a good developer nowadays with respect to Java programmer, not only Java, I think same concept available in other areas, other programming languages, and even front end also. So you have to make sure knowing about this Lambda expressions, that much important nowadays it is. And you know, there is a connectivity between Lambda expressions and functional interfaces. That is also I discussed in the last session. Because Lambda expressions are always an implementation of functional interfaces. Without functional interfaces, there is no concept of Lambda expression. So when functional interface is there, then Lambda expressions are existed. When Lambda expressions existed means functional interfaces are existed. So that is how these two are having a connectivity. So that's why, and nowadays the entire programming is always most of the times happening with respect to functional interfaces and Lambda expressions. So that's why please concentrate and please get the knowledge of functional interfaces and Lambda expressions if you want to become a experienced developer or whatever it is. Okay, so now what is a Lambda expression? Here it is. So we discussed like it's an implementation of functional interface abstract method. So what is the overall concept of functional interface means? It is always having one abstract method. And whenever we are providing implementation for that abstract method, you may go with regular approach or older approach called as implementing a class for that interface, or maybe you are creating some inner class. So there are different older solutions are available. But nowadays it's all recommendation is all about when it comes to functional interfaces, the recommendation is always going with the Lambda expressions. So that means for that single abstract method, whatever we are creating as part of functional interface, okay, so for that single interface we are going to provide implementation means what? A logic. So logic for that abstract method. So that implementation always provided via Lambda expressions in general for the functional interfaces. Now what is the concept of Lambda expressions and why we are calling it as a expression? Okay, why we are calling it as an expression? So with respect to that functional interface abstract method, that is also we are trying to understand. So here it's a very simple guys. So here what you have to remember always one thing is when it comes to Lambda expression means immediately we have to think about what is the functional interface, for which functional interface you are writing the Lambda expression, and for that functional interface what is the single abstract method available. So entire story depends on this single abstract method. So that is what you have to understand. So that means providing writing logic for this single abstract method by using Lambda expressions. We are going to write by using Lambda expressions. So why we are calling it as expressions also we understood in the last session. If you observe here, we implemented couple of Lambda expressions in our last session. So if I take n, this is a functional interface. Yes, and it is having single abstract method called as get loan EMI value. Now whenever we implemented multiple Lambda expressions, see I created Lambda expression 1, Lambda expression 2. So here I discussed a couple of rules also. So how to write Lambda expressions? So if you remember, this is the way formula point of view, you can easily remember. So what it is, for which functional interface you are writing the Lambda expression, that is what functional interface you have to take. For which functional interface you are implementing the Lambda expression, that is what you have to take here. And this will comes under expression name. So nothing but like similar to a variable name, object name, something like that. You can give your user defined, okay, identifier. So that means you can give any name here. So I can call it as a Lambda expression name. Lambda expression name. So what is this is, for which functional interface you are providing the Lambda expression, and this comes under the Lambda expression name. So these are all we discussed in the last class guys. Okay. So I'm just after 1 week 10 days we are discussing, that's why I'm just going bit again. But we discussed all these points in the last session. So it's a very simple. Just revise the old class again, probably today starting with new class. So what I said, and after that, what is this section? And Lambda expression is always having a syntax called as this syntax. So functional interface name, lambda expression name equal to method parameters, okay, and imply arrow mark symbol, and then followed by curly braces you will open, and probably you will have semicolon also sometime. This is the very basic syntax, and we can simplify this syntax also. That is what we will see in today's session. So how to write very simple and lightweight lambda expressions also. Can we, okay, can I say like, can we shrink or can we reduce this way of implementation, or what are the shortcuts we can implement as part of lambda expressions? What are the shortcuts we can follow based on the Java rules and regulations? We will try to discuss. But overall syntax is this is what a basic syntax. So what's happening here for this functional interface? You are providing the implementation. What is the interface name? Calc operation. So that's why you have to take lambda expression name, sorry, functional interface name here and lambda expression name. And when it comes to here, parameters, which parameters? The abstract method parameters. So that's why I said in entire story of lambda expressions, you have to remember always you are providing implementation for this abstract method. Whatever that functional interface is having, one abstract method, that abstract method you have to remember. And these parameters, whatever you are having, that is what you are creating here. So if you have two parameters. If you have three. If you have zero. So the number of method arguments or method parameters of abstract method being used as part of lambda expression. But if it is having two, must and should you have to provide two, okay, arguments as part of the lambda expression, and then followed by imply. Okay, so this arrow symbol implies, that means you are providing the implementation. So that means implementation for what? For entire this method, for this entire single abstract method of the functional interface. So that is what comes under this arrow mark symbol. So this arrow mark symbol is saying like an implementation started for this abstract method. So then you will write your own logic, okay, as per in between these curly braces, and you will close the curly brace. That means this is the end of lambda expression. This is the end of lambda. So in between you written the logic. Like whatever the logic you want to write, n number of lines you can write and you can provide the things. So these are all details we discussed in the last session. So again, just I'm going through because 1 week gap we had. Okay. So now let's start understanding more again about the functional interfaces and how we are going to make sure providing lambda expression in a shortest way or in a different approaches point of view. We'll try to understand. Okay. So let's do one thing. I'll take a new class and I'll provide different functional interface lambda expressions. See here. So I'm using same functional loan, okay, functional interface called as bank loan. So in this case, I'm trying to use same functional interface to write lambda expressions in a easy way and different shortcut ways. We'll try to see. Okay. So now my point here it is. This is the functional interface. So this is the functional interface. So for this functional interface, I'm going to write down the lambda expressions. So we already written, but we will see again the better approach or maybe somewhat shortcuts I'll introduce in a new class now. Now let me take a new class. So it's a class I'm taking. Okay, so let me take a main method also. Okay. So now my next point is, for example, maybe if you taken it as a question, where we have to define lambda expressions. So our answer is we can define wherever we want. Wherever we want. So that means lambda expressions wise, That is what the advantage of lambda expression. That is what the advantage of lambda expression. So wherever you want an implementation for that single abstract method in a different formats, you can simply write lambda expressions for that interface. If it is a older approach, you have to write always a new class. You have to write always a new class. For example, in the last session also, if you observe here, I implemented total 3 lambda expression. Lambda expression 1, lambda expression 2. So like that I written 2 lambda expressions. Now, if it is a regular older approach, we have to write multiple implemented classes. Like bank application implements bank loan, bank application implements bank loan. Like that you have to write 2 individual implementation classes for this interface. But lambda expression, if you observe here, I written inside the main method. And tomorrow if you are having your own method, I mean different other methods also, wherever you want, you can do that. So for example, I'll do one thing. Here I'll write a normal a non-static method. So public void check all bank loan something. I return a non-static method. So now can we write a lambda expressions? So can we write lambda expression for any interface expression? Okay, for any functional interface means yes, we can write. So now for which functional interface we are writing the lambda expression. So assume you are having multiple. So here you have something like calc operation is one of the functional interface. Bank loan is one more functional interface. Like that, as a developer, you created 2 functional interfaces. Now you can provide implementation for this functional interface as well as this functional interface also. Now let's take bank loan with respect to new class, whatever I created here. So my point here it is, I am going to create, first I am taking bank loan. So now my functional interface is what? Bank loan. So that means you are writing lambda expression for the functional interface called as bank loan. So what is the formula I said? How to write functional interfaces? Very simple. So what you have to remember, for which functional interface you are implementing the lambda expression. For which functional interface you are implementing the lambda expression. So that is what you have to remember. Now in this case, my functional interface name is bank loan. Okay, fine. And then I said lambda expression name. So what is this? Lambda expression name. So you can give any name. So for example, here I given ICICI loan something. Okay. And now after equal, what you have to do? You have to make sure number of method parameters which are available as part of the functional interface. Now if you go here, what is the single abstract method available? This is what. So that means as part of this functional interface, you have this single abstract method. Single abstract method, right? Now what I said, the moment you return for which functional interface you are implementing the lambda expression and lambda expression name. So here you have to take the number of method arguments which are available as part of the abstract method. So how many I defined as part of the lambda functional interface? 1, 2, 3. So long, int and double. So I said you have to just take as it is, that's all. Right? So that is what we did in the last session. And once you have done that, take an arrow symbol. So that means now you are about to implement the logic for the this abstract method called as get loan EMI value. Get loan EMI value. And it has to return always a double value. So that's why what I said, the moment you take in these method arguments as it is here and you are started making an array symbol, hyphen and greater than symbol, and then that means you are started writing the implementation. Now I said immediately open the curly braces, end the curly braces, and end with semicolon. So why it is giving still compile time error means because it is expecting always a return double value. So that means now you will write logic. Now in between, see, this is lambda expression starting, this is lambda expression ending. For this lambda expression, this is the starting, this is the ending. It's a block. It's a block. Block means group of statements. So that means you will write your own logic here and assume you made all the calculations. You made all calculations and finally you got the EMI value. Okay. And then what you will do? You will return that EMI value, double value. So that means whatever it is. So I'm just taking a double value like that. See, the moment I return double value, the compare, why? Because this method is expecting always a return value called as double data type. That's why the moment you are returning some double value, it's I mean, now you are done with your lambda expression implementation. So you are done with your lambda method, lambda expression implementation. Now, similarly, you can write one more n number of lambda expressions wherever you want. For that functional interface, bank loan, in any class going further, see, in another class, I already written home loan, car loan, something like that. Now, in another class, I written today as ICICI loan. So that means for lambda expression, you can implement wherever you want for that functional interface. And based on your requirement point of view, you can write your own solutions and you will use that lambda expression to execute the functionality. So while executing functionality also, I told you shortcut. What is the shortcut? I mean, shortcut means we discussed it, how to call the lambda expression. What you have to do? Yeah, if you see here, so lambda expression name and followed by abstract method name and the real values for the method arguments. Yeah, so here lambda, how to execute lambda expression or how to call the lambda expression is lambda expression name. So in this case, what is the lambda expression name? This is what. So take that followed by what is the method you implemented, get loan EMI value. And how many method arguments available? 3. So that means total 3 values you have to pass. Total 3 values you have to pass. For example, in the lambda expression itself, I am writing a logic like this. Calculating EMI value of ICICI bank something, and I am writing principal. So from what is this variable means this variable, whatever you taken here it is. I'm just making somewhat extra logic so that we can easily number of months, number of months and rate of interest. Okay, so just any number of lines you can provide. Now, here what you have to provide? You have to provide the real values for this. So this logic has to be. No, it is simply like calling a method only. Simply, however, you will call the method, same here it is. So now in this case, in general, previously what we used to use maybe object name, but today we are using lambda expression. So that means now you have to provide some values like principal amount is something like 12 lakhs or whatever it is. Some random values I am providing 20 months and rate of interest is something like 6.7 or whatever it is. Now the moment you provided 3 values, so what will happen? Immediately this value will go here, this value will go here and this value will go into this variable. And which lambda expression executed? This one executed. Assume you are having 10 lambda expressions implemented, but you're using a specific lambda expression name, right? So there it will go and it will start entering, JVM enters into this lambda expression and takes all these values and execute all these lines, and finally whatever you are returning, that value being written here also. So if you want, I can take like double, so it is returning some value, right? We can hold it. double EMI amount something. So now sys out of EMI amount something. Run as Java application. So this is all we did in the last session itself. Okay, sorry, why it's not executed? You implemented all this in the a non-abstract method. Sorry, in the non-static method of this class, right? So we have to call. Main method is empty method. That's why you didn't see anything. So to execute this method again, you have to call this method, right? So let me create a object for this class, and then I can call my own method check all bank loans, something like that. Now the moment I call this method, then this method will execute. That means internally lambda expressions are going to be created and executed. Everything will happen now. So this we know that calling one method. So now see here console. Yeah. So we are done. Principal amount, whatever we passed, and also that means what happened? This lambda expression is executed. This lambda expression is executed. And whatever the values you passed, those are all values came, and entire logic will be executed. And finally, whatever the value you are returning, that value is returning here into here. So similarly, how many lambda expressions you can write means you can write any number of lambda expression. So we did same thing in the last session also. But now continuation to this, what I'm trying to say, understand. Okay. Now some kind of shortcuts I'll introduce. Let's see here while writing the lambda expressions. What it is. For example, assume again same functional interface point of view. I'm following the lambda expression. I'm implementing the lambda expression. Okay. Again, this for this functional interface, I'm writing the lambda expression. See here. Okay. First thing is bank loan, for which functional interface you are providing lambda expression that you have to take. And again, a lambda expression name. If you are creating one more lambda expression, that means one more implementation for that abstract method. So that means one more lambda expression. You have to give a different lambda expression name. So duplicate names, you can't use it in the same method level. So similar to variable names point of view, object names, same point of view. Now I given something like HDFC loan, something, whatever it is, some differentiation between the names. Okay. Now I said already, this is all comes under the lambda expression. This that okay, after equals, whatever you are writing, this is all comes under the lambda expression. Now what I said immediately the moment you decided to write lambda expression, I said copy all this, right? So assume this your functional interface is having zero parameters. Then what you will do, for example, if I given a functional interface with a name called as ABC, and assume internal it is having a method called as test method, okay, and assume void method. So I'll take that method. So simply I'll take that. Now this is the method signature I given as part of the functional interface. So here how many method parameters you are having means 0 you are having. So then if it is 0, you will take 0 and followed by the array symbol. But in our case, for this functional interface bank loan, this abstract method is having total 3 method parameters. So that means 100% you have to write 3 method parameters here. That as it is. So that's why what I said take this as it is and copy paste. It's up to your choice. Okay, that is what we did here it is. And then you will provide logic here. And finally, you will return some okay, because it is always expecting a return value of double. So that's why you are writing return and you are ending semicolon. So here I said like you are writing the logic. This is what we did here also, here also. But what is my shortcuts here it is. Now see here what I am doing. If you are comparing the above one and second right now, whenever you are defining the lambda expression, okay, for the lambda expression, you can you have to maintain 100 percentage. Okay, I'll remove this line below. I'll keep here. So what you have to do is, it's up to your choice, guys. It's an optional. Okay, I'm not saying like mandatorily you have to remove and all, but generally people will follow this kind of things. Now what I said, long int double data types you taken, right? So step number one, in this case, we can avoid, so eliminate method argument data types. Method argument data types. So what is the point of method argument data types in this case? Okay, so let's see here, I'm removing method arguments. Yes, you can do that. But but the point what you have to remember is the number of method arguments available, those many argument names you have to provide. So that means in this case, argument names are mandatory. Argument names are mandatory. That is what one thing you have to remember here it is. Argument names are mandatory. So now if you observe here, first one I added in a simple format, and I mean in a pure implementation point of view, I given data types also. But in this case, I avoided writing method argument data types. Yes, it's an optional. Whether you want to write down, no problem. Whether you don't want to write, don't write it. It's up to choice, optional. So it's not like mandatory. So that's why. But now in this case, how it will understand? How compiler knows that what is belongs to what? So what compiler will do is it will always make a mapping. Okay. So the moment you given a comma b comma c, assume you given here a b c something. You can give any argument names. XYZ, ABC, principal amount, rate of interest, number of months, whatever it is. Whatever you given, so what it will understand here it is, A belongs to first long variable, B belongs to integer variable, so C belongs to double data type. So like that, the number of arguments what really available in the abstract method of functional interface. Okay, and same way in the same order it will consider the data types also. As a developer, if you are not written, as a developer, if you written, already you are followed the same approach, right? Already you followed same approach, long int and something, even variable names also you given same as it is. But in this case, if you observe here, I given whatever I want. So for example, principal, I written like amount, months, and interest, something like that. So you can provide your own variable names, or as well as you can write or you may not write the data types. But now my next point is, can I reduce one of the method argument means? No, 100% no. For example, it is expecting this functional interface abstract method is having 3 arguments, but I written 2 arguments. No, it's not acceptable. 3 should be presented. Whether it is 0, then like that. So if it is 0, that means your lambda expression will become like this: a, b, c, and something a equal to, and you will start writing empty parentheses and followed by the arrow mark symbol imply. Okay, so like that you will write. So here what, why we are not provided any method argument names here, it is because the abstract method contains 0. That's why you are not provided. Now in this case it is provided 3. So that's why you have to make sure provided 3 arguments mandatory, but 3 arguments are mandatory, but it's up to your choice writing the data types. Only you can eliminate writing the data types, but internally Java compiler will consider amount is a long variable, months is a int variable, rate of interest as a double data type variable. So like that, it will consider internally. Now same, see I'm writing like something like HDFC EMI values, EMI calculation. So you can write, I'm just making simplification of the process. See now, what you observed, yeah. So now you created one more lambda expression for the functional interface. Now you can call it. How to call it? Same thing. Lambda expression name dot the abstract method name. So what is the abstract method name? Get loan EMI value. And followed by what? You have to pass the real values. So that means I want to 10,000 is the EMI amount and they are applying for 36 months and then rate of interest is 11% or something like that. Now these values will go into here. So that means now the mapping will happen. Amount, months, rate of interest. Similarly, amount, long value. See, for example, I'll try to give here some float value or double value. See here what's happening. Immediately got compiled error. Why? How it knows that it is a long value. So here you are not given anything, right? But internally, based on the functional interface lambda expression syntax point of view, it will consider always this as a long value. So that is what as a developer you defined here. As a developer, I did not define here. It's up to your choice. You are just making a high level lambda expression like that. But it is always a longer value. So that means in this overall discussion, what you understood, you can start eliminating or writing or eliminating. Okay, you can start eliminating the data types while you are implementing the lambda expressions. But internally, compiler will consider same thing. Now, same point of view. If I taken this lambda expression, so sorry, this functional interface. What is this? This is the functional interface, right? So let's do one thing. Now I will ask you, can we write lambda expression for this functional interface or not? Yes. So in this case, this is the functional interface, right? Okay, I'm just making a comment here so that it will become easy for us. Okay. Now, this is the lambda, this is the functional interface I given. What it is, calci operation, and internally it contains this abstract method. Now, how many method arguments it contains? Two. So, if I want to write a lambda expression again for this, same syntax. For which functional interface? This functional interface. And what is our operation name? For example, addition. Add equal to. And then here I can take a comma b. So, is it a valid means? 100% valid. Why? I can give any method argument names. I can avoid writing eliminating data types. Int comma int. You may give int comma int. Then also it is good. Then also it is good. Even if you are not given data types also, lambda expressions wise, nothing will happen. But it's not like I will give only one argument name. No, it's not allowed. Two are there, two argument names you have to provide. But data types and all, you can start writing eliminating. So that's why I see here. And if I'm writing and okay, why it is okay, this is all about import the package because this class that interface is in the different package and you are writing logic in the different package. So that's why import it. Import and all you have to do. Now here, why return some integer value? Why? Because it is always expecting an integer value. For example, assume this is a void, that lambda expression. Sorry, that abstract method. Return type is void. Then no need of writing return. We will see the one example for that also. Okay. Now, see, this is what I'm trying to say. You can start eliminating the data types when you are defining the lambda expression as a shortcut point of view. Now, if you go with the old approach, what you did, you given integer value 1 comma integer value 2. Int to int everywhere you given data types. Now you can start eliminating the data types. See here, I am removing data types. Yes, internally Java compiler will understand value 1 is a integer value, value 2 is a integer value. So that is how it will understand. So that is the point we discussed so far right now. Now my next point, continuation to that. Yeah, so I'll take here. So that means what you understood, how shortcuts point of view we are trying to understand. So the moment you are defining the lambda expression. Now, point number one more thing. So that means what you understood right now is point number one. Writing data types of method arguments of writing data types of method arguments as part of lambda expression is an optional. It's an optional. So internally compiler will take it. So that is what point number one we discussed as of now. Now next point, see here. For example, assume I'm writing one more lambda expression. Um, Again, same functional interface only will take. Okay. So let's take for which functional interface? Bank loan. And I will take a new something like lambda expression name, access loan or whatever it is, access bank loan or whatever it is, equal to okay. So now our story is all about writing the lambda expression, guys. So one shortcut we understood from previous one to this one. Now assume tomorrow you have only one line of logic. Assume your method, my use case here it is, my use case in this case is logic of an implementation. Logic of an implementation is only one line. So logic of an implementation is only one line. Yes, sometimes, right? Sometimes only one line implementation might be available. Only one line. For example, if you see here, 1, 2, 3. Assume 3 or 10 lines or 15 lines. In this case, assume 10 to 15 lines, something like that. But tomorrow, you have only one line of logic. For example, assume in this case, addition. So what is the point of addition in this case? Give me a moment. Why this error is coming? This is a functional interface. Okay. Because of this line, it is coming below error. Leave it. So now see here. Yeah, sorry. I can come back here. Now my use case is tomorrow when you are having a functional interface, you may have only one line of logic. Yes, if you observe here, now how many lines of logic are written? Only one line. Not more than one line. Not more than one line. So that is what my use case. When your logic is having only one line, so what else we can do? So now assume this is having only one line. Like for example, a plus b. Yes, obviously, right? A, b variable. But if you observe here, open curly braces, closed curly braces, how many lines of logic it is having? Only one line of logic. So in such case, what else I can do? What else we can do along with the lambda expression implementation? That is what my point. Now, for example, I'll write down this and then again we'll come back here. So now, first point, what we understood, you can take any method argument names. You can start eliminating the data types. So in such a way, I taken something like a comma b comma c also, it will work. but make sure taking always meaningful variable names. So that is how what I did. So for example, I taken amount, principal amount, and followed by months, and then followed by rate of interest, something like that. I taken a meaningful variable names. Yes, you can take. Followed by array symbol. So hyphen. Now the story what I said, you have to write always one line logic you are writing here. So for example, assume you are writing only one line logic here. Maybe some reason. So I'm writing something like 55,000 or something. Assume you implemented a formula in one line, guys. So that PQR by 100 everything. That means in this case, how many lines of logic lambda expression body contains? How many lines of logic? How many lines of logic in this case is only one line. Only one line. Only one line. Yes, sometimes you may have only one line of logic. In such case, what else you can do is, let's see here. Okay, so the same expression how I am writing, let's see. Um, okay, I'm just commenting down the above lambda expression because I want to use same name one more time, right? So that's why I just made a comment. So same thing, if I am writing in a different shortcut way, let's see here. Now let's go with copy paste. I'll do copy paste only, but see the difference between above one and second one. Yeah, so this is the one we written, and this is the one I am writing now based on a shortcut point of view. So what I am doing here, whenever you are having the moment only one line, you can start eliminating the curly braces also. If you observe here, what I am trying to do, let's understand. Even I deleted return also. So now this implementation is equal to this implementation. So what I did, the moment whenever you are having only one line of logic, whatever you are having, whether it is a okay non-void method, that means something you are returning, you can start returning that value directly. So that means assume tomorrow you return some formula here, amount plus amount into so something, I don't know that formula, so I'm writing just randomly like this, rate of interest and followed by 100. Now what will happen automatically based on the values, everything will be one line of logic you are having. So now this, okay, I'll write like this. Yeah. So now this one line logic, whatever you used curly braces, ending with semicolon, return keyword, everything I just made into a small shortcut point of view. See, now ultimately what I did from this level to this level, I brought it into a shortcut point of view. And now in this case, whenever you are having, see, this will work only when you are having one line, guys. If you have more than at least one more line, that means two lines, again you have to go with this approach only, opening the curly braces. If you have only one line, then you no need of curly braces, as well as you no need to use return statement also. So that means internally compiler will understand like this again. So that means the moment whatever the calculation happened, whatever the value coming here, so that is returned always. So that means internally this here compiler is going to consider as a return keyword. So the result of this expression is considered. Now after array symbol, this comes under the implementation. So I written in a shortcut point of view. So that means I eliminated curly braces as well as return statement also. Now same point of view, can I call this lambda? Yes, 100%. See here, I am calling access loan dot, what is that method name? Obviously now it's all old point. So the method name is get loan EMI value, and some values you have to provide, something like whatever I am providing, 20,000 and 60 months, and something like rate of interest is 7%. And this is returning always a double value. So sys out of checking access bank EMI value. Checking Axis Bank EMI value. So now this will return always what? Double value, right? So I can take double EMI value. Yeah, EMI amount equal to something I'm taking. Yeah, I mean, I'm just calling that lambda expression. Now see here automatically. Yeah, here. Now sys out of EMI amount. So the moment I'm calling, what will happen in this case is internally, yeah, here. Yeah. So whenever this line is, so now this is called as lambda expression. Now this is you're executing the lambda expression. So you called what access loan. So then immediately Java internally jumps to this and it will start implementing, executing this implementation. So whatever the values you passed, 2000 goes here, 60 goes here, and 7 value will goes here. So this formula this we understood in previous example. Now our concentration is on the body. We have only one line. So that means now 20,000 into and 60 into something like 7 in by 100, that calculation will happen. Whatever the remainder value you got, that is what returned back here. Okay, that division value result is returned. So you are not use return statement, but still it is returning. So this is the shortcut ways we can implement for the lambda expressions. See guys, please practice. I'm telling you right now, I will open and I will show you after this session how much important lambda expressions are. Right away I will show you if you want. Okay, so I'll show you if you want, but definitely you should practice all these approaches. So otherwise it's very difficult to understand stream API, and if you are not understanding stream API, you will not get the job. I'm guarantee about it. So that's why I'm going this much slow also, and don't think like it's not useless. Okay, so let's see here now. Now I can call it as, so run as Java application. See, I got something like 84,000 or whatever it is. So that means what happened? You written a lambda expression in a shortest way. Now, can I override this lambda expression also? Means yes. See here, how many lines of logic? One line. And a plus b is the main most important thing here, and you have to return that result also. But one line logic you are having. So that means in this case also, I can eliminate writing the curly braces, and I can eliminate return keyword also. See, done. One line I written. Now similarly, if I want to write subtraction, multiplication, subtraction a minus b, multiplication, total three lambda expressions I created. Okay, now whatever I want to call, I can call. So now I want to add two numbers. Add dot, okay, something I given directly add something like that. You can give different method name also. Operation something like add dot operation, subtraction dot operation, something like that. But you are able to create multiple, something like that, multiple lambda expression. You created one line lambda expression. Assume now your requirement is having more than one line, then again this formula will not. Then what you have to do, then open the curly brace. If you have more than one line, open the curly brace and put that logic inside the curly braces, and then again at the end you have to use the return statement also, in case if it is expecting a return value, like that. Now, for example, I'll create one more lambda expression, sorry, functional interface, um, testing, something like that, finish, and at the rate, functional interface. The moment I added functional interface annotation, what is the advantage? It will make sure always one abstract method is available. So now see here, I'm writing, you know that if you are not writing public all this, but abstract methods of an interface always are public methods. Now I'm writing void accept, something like that. So now Yes. How many abstract methods I have means one abstract method I have, right? What void return type? That means there is no. I mean, this method should not return anything once implementation is available. Void. So that means nothing to return. And accept is the method name. And how many method parameters? Zero. So now it's a functional interface. It is a functional interface. Can I provide implementation for this functional interface via Lambda expression? Means yes, I can do that. I can do that. So let's see here. I'll write here. So what is my functional interface name? Testing. Okay. And what is my method? I mean, what is the single abstract method? This is what. See, by default, it is a public and abstract method, guys. So in interviews, they will ask you. I mean, this is the concept we discussed in the interfaces level itself. So now by default, it is a public and abstract method. Even though if you are not added keywords, internally compiler will consider public and abstract. So with these points we discussed, you don't need to specially write public and abstract here. If you are writing, nothing will happen. If you are not writing, also compiler will consider public and abstract methods. Public keyword and abstract keyword being added. That those details you have to know that. In interviews, they will give you some interface name and they will ask what is the default access specifier for this method. Then you have to select it is always public by default. Can we create private abstract methods in the interface? No. So these are all small hidden interview questions. You have to remember and you have to practice it. See, I can't make anytime private abstract methods. So there is no point of making like that. It is always public only. Okay, fine. So these are all interfaces concept. I'm just making. Now see here. What is my method name? This is what I'll take as it is. Okay, so this is the interface name. This is the abstract method name. How to write? Same thing. Take the interface name, testing, and then something like test1 equal to, so lambda expression name. Followed by, now here I'm taking parenthesis, 0. Why 0? Because there are no arguments. That's why no arguments. Now if it is having only one line logic, then you don't need to write this curly braces also. If you have more than one line, you have to go with curly braces. And this is returning always void. I mean, this method return type is void. So that means you should not return anything. Now you should not return anything. For example, I can write a sysout. What sysout will do? Sysout will do whatever you given, it will print, but it will not return anything. Println method return type is what? Void. If you go to the println, what return type is void? So that means whatever you given value, it will be printed. Test case 1, test case 1, something like that. It will print and that's all. It will not return anything. How many lines of logic I have? One line of logic I have. So that's why no curly braces, no return. I mean, first of all, you can't use return also in this case, even though you have more than one line. For example, see here, I'm writing one more lambda expression. Testing test2 equal to, I can I take more than argument names here it means? No, because your abstract method itself doesn't have any arguments. So you can take that. Now assume my method is having more than one line. Then again, you have to go with curly braces. So block means what? More than one line. So whenever you have more than one line of logic, then again open the curly braces. Now here again I will can write down more than one line of logic. Test case 2, something like that. Checking username, something, whatever it is, more than one line. So here are you using any return means? No. Why? Because this method itself void method. So you don't need to use return. That and all you know that from our basic methods implementation. So what is the point you understood here? It is the moment you are having only one line of logic, you know you can avoid eliminating the curly braces also. You can start eliminating the curly braces also. So like that, you have to provide implementation, guys. Like that, you have to write start implementation of lambda expressions. We have to start writing implementation for the lambda. So these are all hands-on, or these are all that much confidence when you will get is if you are doing lambda expressions. I mean, you practice multiple lambda expressions, and if you are executing same lambda expressions in same way also, you will get it. See here, for example, I want to execute test one. Yes, test one dot what method name. What is the method name? Accept. So now if you are calling this, then immediately what will happen? This lambda expression will be executed. If I am calling test2 dot accept, then what will happen? This lambda expressions are executed. Run as Java application. See here, at last you can see, I think, test case 1, test case 2, test case 2. So two lambda expressions are executed. But the way how you written lambda expressions, you have to understand. That is what we discussed in today's session. So first approach is, it's like all the details you provided. And if you want to become I mean, if you want to make sure somewhat shortcut point of view, eliminate the data types. That is, you can do always. But again, when you are having only one line of logic, you can eliminate writing the curly braces also. That one line logic, you can directly write like this. If you have more than one line, there is no choice. You have to go with curly braces. If you have only one line, no need of curly braces also. So that is how you have to write down the lambda expressions. Now, if I taken any lambda expression, can we write our own lambda? So can we taken any functional interfaces? Can we write lambda expressions means? Yes, we can write easily. So I already told you how to write a good way point of view. For example, I'm not taking these topics today. I'll take this tomorrow. So we have the four most important predefined functional interfaces, guys. Predefined means developed by the Java language, given by the Java language. We have total four predefined functional interfaces. I'll explain these four tomorrow. It's functional interfaces only, and you are not, as a developer, we are not defined. Java language defined. That's all. But ultimately, it's a functional interface. And we have to write implementation via lambda expressions with lambda expressions for the abstract methods of these four functional interfaces. And we will understand there is some specific purpose they given these four predefined functional interfaces. One is function, second one is consumer. Very important. In interviews also they will ask you sometimes, do you know any predefined functional interfaces? Functional, supplier, and followed by that predicate. The most important functional interfaces, predefined four functional interfaces. This we will discuss one by one tomorrow. It will take one class. But before understanding this, you have to know all these points what we discussed till today. So that means simple. The moment what is the functional interface, what is an abstract method, single abstract method, and the moment you are writing the lambda expressions for that functional interface and abstract method, how you written the lambda expressions. The how many ways you see. We written almost 10 to 12 lambda expressions, guys, as part of our topic itself, explanation itself. So now as a practicing, now you have to practice multiple examples. Take same calculator, I given one calculator, okay, and write your own lambda expressions. Make here method name as operation, then it will become very good. You can write subtraction, multiplication, something like that. So here you can give where, yeah, here. The moment you're calling, you have to call with that method name, that's all. Now you can make sure something like addition, subtraction, multiplication point of view. Here I written, right? So now addition, subtraction, multiplication. The moment you're calling, add dot operation, and then you will pass 10 comma something values, two values you have to pass. That's all. So that means the moment you are calling this lambda expression, in this case add, so it will come here, and a comma b 10 value and followed by 30. So a plus b 10 plus 30 40, and 40 is being written back again. 40 is being written back again because it's having a integer return statement. So that is how you have to understand the lambda expression. So please practice all these examples and make sure practicing the shortcuts also. And I told you, right, I'll show you the importance of lambda expression. I don't know whether I have my workspace or not. I'm not sure. I'll show you. But without this knowledge nowadays, you will never ever get a job, as well as you can't work on the real time applications also. That much crucial these things became nowadays. Functional programming, functional interfaces, lambda expressions, because these are all things again used as part of Stream API. And you know the demand of Stream API nowadays with respect to Java language. So to understand Stream API, you should know lambda expressions, functional interfaces, and then tomorrow these four functional interfaces also you have to understand. So without knowledge of these four predefined functional interfaces also, again you can't understand the Stream API. I don't know where I left it. I think I'll show you here. Even I'm not sure whether it is opened or not. Yeah. So if you see, I think it's public only. You can also access. I mean, I just made my own practice like 4 years, 3 years back point of view. But I'm just trying to show you. See how things are happening with respect to Stream API point of view, right? Streams. See, everyone has to do the practice, guys. Whether Dilip, whether you or me, what it doesn't matter. So everyone has to do the practice. Otherwise, see, for example, I'll open one of the thing, employee operation something. If you observe here, what you understood, lambda expression, Stream API. This is entirely Stream API. So that means the moment you are opening lambda expression, and what is this? Argument name 1 comma 2. So that is what we discussed today. We are eliminated the data types and we are direct written. Why one line of logic? That's why there is no written statement also. And if you see here, again, what lambda expression? Again, lambda expression. Again, lambda expression. And you know, if you are having one parameter also, you no need to use that parenthesis also. You don't need to use parenthesis also. That's what. So for example, I'll cover this example also. Switch. Yeah. So what is the point they are trying to say here? It is. I mean, for example, I'll cover that tomorrow as part of this consumer or supplier point of view. But anyway, I'll just give you. For example, assume you are having a ABC functional interface, and you have void some operation or whatever it is, and you are having integer a. So this is your functional interface. This is your functional interface. Now in this case, lambda expression point of view, what I said, shortcut point of view, you can write like this. I said you can take a and followed by symbol, and if you are having more than one line all this story, you know that. Now here, when you have only one argument, you can no need to maintain this parenthesis also. That is what one small thing. Only one parameter you are having. For example, I'll take that one also. Hmm, functional interface. What I will do, print info, something like that. Okay, so I'll make this as a functional interface, and then I'll add one abstract method. So for example, I'm making void with print string. Sorry, print, and I'm taking string as a argument name. So this is a single abstract method again. Now I want to write lambda expression for this. So see here, I come back to last line. Yeah. So I said, right, it's very easy when you are taking, until you are getting comfort, make sure like this. Then it will become very easy for you to write lambda expression. What is the abstract method? This one. Until you are getting comfort. Now this is the functional interface. This is the abstract method, right? Write lambda expression. How to write first for which functional interface you are writing print info, and then something like whatever it is. You can take some lambda expression one, print one equal to. Now you can start writing the what I said. One thing is this is the one approach, taking as it is method argument. I mean data type, including data type. See how I can write how many how many ways this one. Sys out of info. I can use that variable directly. Yeah. So see lambda expression only I written. Lambda expression. So I written I mean including data type. Now for example, shortest way how I will write, let's see, print to 2 I will take simply name purpose, and I can eliminate this. That is what I said, right? This is one way. Now see how I am writing third way. I mean I'm going to make it more simplified way. Print to 3. I said whenever it is one line, you no need of curly braces also. So that's why I removed curly braces. That is one approach. Now see I am writing one more way. This is the point, new point I am discussing now. Print 4. Fourth lambda expression simply. Now what I said, the moment you are having only one, you no need to maintain this one also. So that's all. It's up to your choice, guys. Nobody is forcing you like you can't do that. But tomorrow when you are going, for example, assume you open my program like this, then you should not get a confusion like why Dilips are not user parentheses. It's optional. See here, I used parentheses here, but I did not use here. Sometimes maybe flow I can also use. Sometimes I see I did not use it again. But wherever you saw array symbol, nothing but it's almost what? Lambda expression. And that means this is a lambda expression. So one argument and followed by one line statement, one line solution, one line solution. So like that. Not only this, even if you go here, see this is a lambda expression again. Value, one line. So I can use parenthesis. I can avoid parenthesis also. So that's what I used parenthesis. I avoided parenthesis. But when it is possible, when you have only one. Now, for example, you have two arguments. Can I avoid? See here. Again, you got a problem. So only one argument is available. Then you can avoid parenthesis also. You can avoid parenthesis also. So these are all things you should know, guys. Otherwise, that's what I'm telling you. Tomorrow, if you open this program, how will you understand if you know all these points? If you don't know all these points, see, this is very shortcut. I mean, very small examples. But when you go into real-time point of view, you will see a lot of. Even lambda expressions point of view, see, single arguments. That's why I did not use any parenthesis also. It's an optional. You can use parenthesis also. You can use parenthesis of yes. Yes, you can do that like that. So map. So something. This is all my practice. Probably 4 5 years back. I did 3 years ago. I pushed into GitHub, but actual practice I did 4 5 years back when I'm learning my own stream API point of view. That's what I'm trying to say. When you are, whether it is a Dilip or someone else, it doesn't matter. Everyone has to do practice. Everyone should learn at some point of time. So then only you will become some bit expert in everywhere. So this is what predicate I will explain tomorrow. That's what I said. Predicate is the most important thing. So if you don't know this predicate, supplier, consumer, functional, four functional predefined functional interfaces, then again understanding the stream API is also difficult. But to understand again these four, please practice the examples what we discussed so far today and last session also. Then automatically you can understand all this thing. Now if you are done with this four, then tomorrow you can work with Stream API very easily. Once you know the collections framework, the moment whenever I said predicate, function and filter, all these things, then for example here if you observe something filter, something like that, you don't know anything, but I'm just telling you. Here it is predicate being used. In this case, whatever I highlighted, it is a predicate implementation, predicate functional interface implementation. So that means tomorrow, if you don't know what is a predicate, then you can't understand Stream API. Then you can't understand Stream API. For example, map. Map is all about internally takes functional interface, functional interface. So that means this function. If you don't know what is a function, again, you can't understand map method of Stream API. So that means you can't understand the Stream API. So predicate, function, similarly supplier, consumer, all these things are being involved heavily in Stream API. So that's why just we will see more discussion about each and everyone tomorrow. But to understand again all this, you should practice all these shortcuts, this how you are writing the lambda expression. It's you can do everything. Okay, so that's all for today. Probably we'll connect tomorrow with these four predefined lambda expression interfaces, and then we will see. We will move to the new topic once we are done with this. But very easy. These four we are not implemented. Java provided, but ultimately functional interface only. So that means you have to write lambda expressions. But for some specific reason, Java given this four. At what scenarios you have to use, we will try to understand one or two scenarios for every functional interface. And we should have this knowledge also to understand Stream API very well. To understand the Stream API very well, we should have all this knowledge. Okay, otherwise it's very difficult, guys. So lambda expressions point of view, whatever it is. Even see, I think we can take a user defined class also. There also we define lambda expressions point of view. Employee objects. I'll give one complex example tomorrow. We will see one thing with some user defined object. Instead of we taken as of now today integer long double, right? Tomorrow I'll take a object also as part of lambda expression. So that means I'll make a note. Otherwise I'll forget lambda expression with objects. So simply like that. So I'll discuss this. So how to lambda expressions defined as part of the objects also. We'll take small example. Okay. So if anyone wants, you can go with this. I think this is I made it as a public only without law. Yeah, you can access. This is a public repository. So whatever the practice I did so far here, you can check here and you can practice these examples also. These are all. These are all my practice, guys, which are being asked in interview questions also. So what is a arrays level? If you want number of arrays interview questions, you can find out here. And design patterns point of view, something I made my own things here. Lambda expressions point of view. So I practice a couple of lambda expressions and even not only practice, these are all things. This repo is having a lot of interview questions also. I mean, if you observe here, Steam API only, especially, these are all interview questions only. Can you get age count greater than 25? So these are all interview questions only. Whose gender is female? I want all female employees. I want male employees by using Steam API operations. So now like that, if you want all this, you can access this URL. This what this GitHub repository, Dilip IT Academy. So you can see here. I think you are having a lot of other repositories also. But please make sure you are also getting knowledge of GitHub. It's a good thing. It's a mandatory thing to know all these things.